everyone. In this lecture series we are going to start with the new topic, that is numericals on threaded, that is bolted joints. As we had a basic introduction to threaded joints and their applications, here we go with the few numerical and concepts to solve the problems on eccentric loading for threaded joints. Let's start with one numerical where given parameters are: a bracket is fixed to the vertical column by means of 4 identical bolts. So here you can see this is a bracket which is fixed to this vertical column. We have 4 bolts which are identical in size, so 1 2 3 4. The distance between each bolt is 100 mm, while the load is 25 kilonewton, and the distance of the application of load from this action of line from this bolt system is 100. Permissible shear stress is 60, that is tau, and we need to design or determine the size of bolt. So just consider this diagram. Load is applied here with the eccentric small e values 100 mm. So looking at the diagram, you can see the CG of the bolt system is at the geometric center of this plate. So that means this distance 100, 100 and 100. So the CG of the system is somewhere here in between of this 100, that is from this bolt, let's say 1, 2, 3 and 4. From bolt 2 and the 3, CG of the system is 50 mm here, 50 mm downward. For bolt number 1 and bolt number 4, the CG distance is this 100 plus half 50, that is 150 for this bolt as well as for this bolt. So let's see these calculations. The given total load W is 25 kilonewton, tau E value, that eccentricity, and number of bolt 4. As discussed, CG of the system is at geometric center. So primary shear force is, let's say, Fp, that is same for all bolts. So Fp1 is equal to Fp2 and so on. So Fp is total load W divided by number of bolts, while as discussed for bolt 1 and 4 distance is 150, and for 2 and 3 that is 50 mm. This you can see easily from the diagram. Now considering as the total load is transferred at the CG of system, which will generate the moment, which we can write the equivalent equation as we discussed this equation. Total load into eccentric value, eccentricity value, that's 100. So W is given. So W into E is equals to secondary shear force, secondary forces on bolt 1 into L1 plus Fs2, secondary shear force into L2, secondary force on bolt 3 into L3, and so on. Replacing the value of Fs secondary force by small w into L1, Fs2 in W into L2, so that will become W into L1 square, W into L2 square, and so on. Whereas W is the intensity of the load, the unit is Newton per mm. So this term becomes capital W into E is balanced by 4 bolt movements which is opposite in direction. So Fs1 into L1, and that Fs1 is replaced by W into L1. So that term becomes L1 square, L2 square, and so on. In this numerical, as L1 and L4 are same, so it is twice W L1 square, and L2 and L3 are same, so it twice L2 square. Rearranging the equation, so this WE divided by this common term 2L1 square plus L2 square, you can get this small w as intensity of the load, Once we know the value of small w, referring this diagram as discussed, transferring the total load from eccentric value to at CG, that will create a moment here clockwise. So accordingly, the secondary forces at every point will create opposite moment. So that's why Fs1 is moving in this direction, means it will create, as this moment is clockwise, so Fs1 at bolt 1, this will be anti-clockwise. Similarly, Fs2 anti-clockwise, and Fs3 and Fs4 will be in the same fashion. Now Fp1, as W is at CG downward, so all primary forces at bolt 1, 2, 3, 4 will act vertically upward. So all Fp1, Fp2, which is same, so I am just writing Fp vertically upward, and as moment creating at CG is clockwise, the Fs1, Fs2 will be in opposite direction of that. For bolt 1, the distance from CG as this 100 plus 50, similarly for L4 150, and L2, L3 as discussed, total 100, so 50 and 50. Now looking at the resultant shear force, as here we can see easily, for bolt 1 and 4 it will be maximum. So considering only these two values, Fp1 plus Fs1 square plus 2 Fp Fs cos of theta. It's a basic equation which we had in the vectors from your basic 12th physics. Now putting the values of Fp1, that is Fp1 constant value, Fs1 cos of theta, here you can easily see the theta is 90, so that term will simplifies to only the Fp square plus Fs1 square, whereas Fs1 can be found out by using small w into L1, where L1 is this 150, small w is 50, so that's why you will get this answer. So resultant force on bolt 1 is this. To find out the bolt dimension, tau is equal to resultant force divided by cross sectional area, that's AC pi by 4 DC square, so that's core diameter, which is 14.39 mm. For coarse thread, the relation is given by 1.19 times DC. So that is D is coming out 17.13. Round up to next value, D18, that is M18 bolt is used for given application. Next numerical, a steel plate subjected to force of 3 kN is fixed to vertical channel by means of 4 identical bolts. The bolts are made up of plain carbon steel 45C8 with yield strength SYT. Required factor of safety is 2. Find out diameter of bolt. So it's something additional parameter SYT and factor of safety is given in this numerical, and the positioning of the bolt is something different compared with the last numerical. So here the arrangement of the 4 bolts are arranged in this fashion. The distance between these lines is 100, and from this bolt is 100, and this application of fluid is 3 kN and its distance from the bolt is 200. Consider this distance to this is 100 mm. So for this given, again here you can see the CG of the bolt system is at geometric center here, which is this distance 100 and this is 100. So it is again symmetric condition of the bolt and the plate system. So CG is somewhere here, and accordingly this all 4 bolts will have a distance L1, L2, L3 and L4. So that's we will discuss the given parameters and the loading diagram. So let's consider the CG of bolt system is here, transferring the total load W, which will create a primary force on each bolt as it's vertically downward. So primary forces will be vertically upward at each bolt. Let's say 1, 2, 3 and 4. So Fp 1, 2, 3, 4 as F. So FP will be vertically upward. Then transferring the total load at CG, which will create movement here again clockwise. So compensate that, all bolt will have anti-clockwise movement. So let's say at secondary force at 1, so joining this 1 with the CG, that the length is L1. Similarly bolt 2 with the CG, that distance is L2. So perpendicular to L1, the secondary force will act at point 1, which will create anti-clockwise movement. Same Fs4 anti-clockwise to L4, Fs3 and Fs2. From the CG, the distance of this L2 is this distance 50, as well as this distance is 50, because it is a square of 100 by 100. So now how to find out this L1, L2? By simple Pythagoras theorem, because this L1 or this L4 is the hypotenuse with the height 50 and this base 50. Primary force will be again same, W upon N. Eccentricity here, E is equals to, from the loading application, from the numerical you can observe the distance is 200 plus this distance is 50. L1, L2, L3, L4 are all the values are same because it is symmetric. So this is 50, this is 50, and it is same for all the bolts. It may be different for other numericals. So for every time you can calculate the corresponding length by hypotenuse. Again applying the equation, total load W into E, transferring that moment at CG, equal to secondary force balanced by each bolt, that is Fs1 into L1, Fs2 into L2, and so on. Fs1 is replaced by small w into L1, so that become L1 square, and this equation is useful to find out small w, that is intensity of load, that is Newton per mm. From the figure it is clear that as load applied is here with the eccentric value 200 from CG 250, so bolt 1 and 4 are subjected to maximum loading compared with the 3 and 4. It can be observed by using just by nature of Fp and Fs at each bolt, because at 1 Fp and Fs1 nature similarly here is greater, means it will create a larger resultant moment or resultant value of force at bolt 1 and 4 compared with 3 and 2. So we are considering bolt number 1 and 4. So for this theta is tan inverse of 50 upon 50, because that is clear. The theta is can be easily find out from this distances, because that is theta, which is equivalent to same value here for both, because distance this is 50 and this is also 50. So that is tan inverse of 1, which is 45 degrees. So theta value is 45. Considering bolt 1 and 4, secondary force will be W into L1 or L4. Putting the value in the resultant shear force equation, cos 45, the resultant force on bolt 1 and 4 will be same as 3225 Newton. For shear stress calculation, allowable shear stress is always shear strength divided by factor of safety, whereas shear strength is 0.5 times SYT, because in numerical they have given yield strength value, we want in shear. So in tensile this value is given, so 0.5 SYT divided by factor of safety, which will give you allowable shear stress. Putting this value in the equation of Fr upon AC, where Fr1 is the resultant force shared by bolt number 1 divided by AC, pi by 4 DC square, that is core diameter of bolt. For coarse thread, the relation is 1.19 times DC, so that is 7.82, round up to next digit. So bolt size is M8. So that was the problem, 4 bolt system, eccentric loading with symmetric values and the distances from the CG. and we can easily find out all the L1, L2. Next problem, the bracket is fixed to the wall as shown in the figure and there is no preload in the bolts. That's different problem. Again, it is referred with few diagrams. You can relate both the views. Loads are made up of, actually the corresponding this bracket is fixed to this wall, and the material for particular bolt systems is sigma YT 380 megapascal. Factor of safety is 2.5. Additional thing in this third numerical is we need to use a maximum shear stress theory, and we need to find out the cross section of the bolt. That means we need to design the size of bolt. F here, as it is mentioned clearly as F, otherwise it is equivalent to the W in all previous numerical. So that is again equivalent to capital W. Same, just we are using another notation. E here, the eccentric distance or eccentricity is 10 mm. L1 and L2. F is given, that is our capital W. L1 and L4, consider the now this 1, 2, 3 and 4. So 1 and 4 distance from this each will be same, whereas for this bolt number 2 and 4, 2 and 3 will be same. That's why L2 is equal to L3. This 2 and 3 will be same, and L1 and L4 will be same. Distances are given. SYT and NF is given. Now in this numerical we need to use a maximum shear stress theory, as here direct shear stress induced, which is similar to what we calculate primary shear force FP. We are using a direct shear stress in bolt, that is Fs. W upon N, same here, W value is as we are using notation F. So same equation, number of bolt here 4. Direct shear stress in the each bolt equivalent to, which can easily find out by Fs divided by AC. You can use this force here, Fs divided by cross sectional area. So now we'll take this equation as it is, Fs upon AC. Next, tensile stress in the bolt system or bolt edge. Now here just consider we are taking the moment about tilting edge. The tilting edge means here in this numerical here, when the load W or the F is applied, this is our tilting edge, so that will try to pull down this bracket like this. Now taking the moment about that tilting edge, which is similar to the last equation, capital W into E, here that W is replaced by F, equivalent to W, that is Fs, which we have written in the last equation. Now we are replaced by W into directly L1 square. As L1 and L4 are same, so I am writing directly W 2 times W L1 square 2 times W L2 square. Now this value of F or total load is given, L1 L2 is given. The intensity of the load can be found out easily. Now addition to this, the tensile force is most heavily loaded in the bolt as bolt number 2. So as you can easily see, it is the bolt number 2. Why? Because from the diagram you can see this is bolt number 2, means this and this. These two bolts are subjected to maximum force, means they are going to, as our design bolt, compare with 1 and 4. So here I am considering bolt number 2. So that is W into L2. That will give you the value of tensile force in the most heavily loaded bolt. So for the same bolt, bolt number 2, I am using the equation Ft upon AC, calculating those values Ft AC in same equation format. Maximum shear stress theory for bolt number 2, by applying the equation tau max is equals to square root of sigma by 2 square plus tau square. In terms of AC, we know both equation, and just by putting the tau max in terms of AC, you can find out bolt dimension, and that is allowable shear stress is 0.5 times SYT divided by factor of safety. SYT and factor of safety given, so you can find out tau allowable. For this, putting the equation which we have calculated in terms of AC, you can find out the core diameter DC, and by the relation for coarse threads 1.19 or DC upon 0.84, the nominal diameter D can be found out as 13.3, so round up to next digit as 40. So for this case, maximum shear stress theory is utilized to find out or to design the bolt system, and here the answer is M14. So M14 bolt is used. I hope you have watched all the previous content to understand all this numerical. It will help you to understand the concept. Few problems are given here for practice which will help you to build the concept again. The answers is described in the comment section. Here the column and the beam having 4 bolts, geometric center to load applied. Here they have given notation P, you can take W. This value of E and the P I have mentioned here, you can take any other values to just cross check your values answers. Loading diagram here again, W, moment created at CG, so accordingly primary forces and secondary forces will create the moment as it is clockwise, so anti-clockwise moment for secondary forces. Second numerical for practice is given. A bracket again fixed to wall, you can say. Similar case what we had in the second numerical. The distance is 300 and this is 150. Interesting numerical because here we have 3 bolts and this diagram is for reference. Try these 2 numericals and in the comment section you can ask doubts. I hope you watched this content very carefully. It will help you to build your knowledge as well as understanding the design of threaded and bolted joint. Thank you.